All right, so this is 6.3, graphing exponential functions. So this is kind of like a little thing on its own here. And have you guys ever heard of, it's calculate 84. Have you guys ever heard of growth and decay?
Yeah.
You guys have? In what context have you heard it, Neve? Okay. In what class did you hear about it in? Ooh. Science class. So exponential growth and exponential decay are used all the time in science. A big one that is used is carbon dating. What is carbon dating? AJ? Yeah, it's exactly it. It's using carbon to date. Okay, not to like take out to dinner, but like to figure out how old something is. All right, so what they use in science class, Sean, is like something called a half-life. So every, I guess, organism in the world has carbon in it, and carbon decays at a certain rate. So based upon how much carbon is in something, they can figure out how old it is, because they can take that, they can measure the level at one time, and then they can see how much, you know, it has in it then, and then they can work backwards from there. Okay? Does that make sense to you? But this is how they do it. Okay? Found it? Cool. So an exponential function have the form of a, b, x, where a, b, and x are any real number. So a is kind of just, you know, think of it like a coefficient. B is your base, and x is your exponent. So the domain for exponential functions are all real numbers. And the range is going to be greater than 0. Okay. Kevin, you Gucci? You got it? All right. So there are two types. Okay. Which one's which? Harshan, which one is the blue one? Remember, I talked about two so far, right? What were the two words? Two types of exponential functions. No. Neve, do you remember what they were? Growth and decay. So which one of these is growth and which one of these is decay, Neve?
Blue is growth, red is decay. Blue is going up, so it's growing, and red is going down, so it's decreasing the decay.
Growth, decay. That was a great explanation. All right, so this is a growth function because it's going up, and decay is red because that's going down. Okay, now there's kind of like a little difference here because this says f of x equals bx, and this is f of x equals, okay, bx as well. So what's the difference here? Okay, do you guys know the difference between the two? Oh, do you know the difference? Okay, the difference is this. In the growth function, okay, b is going to be greater than 1. So if b is greater than 1, it's a growth. For decay, all right, we're going to say b is less than 1. Okay, now I'm not going to talk about what happens if like b is negative. So for us, We're only talking about when b is positive, okay? Because when it's negative, it just kind of like ping pongs around. So I don't want to go into that. All right. So b has to be greater than 0. In this case, for us, it can be other numbers, but just for here, b is greater than 0. So b is greater than 1, and then b is less than 1. The reason why b is not 1, Sophia, is because if b was 1, it's just going to be like constant. Because 1 times 1 times 1 is always 1. All right? All right, so this is why we need a calculator, because we are going to graph these functions, okay? So we have 3 functions here. F of x equals 2 to the x, f of x equals 4 to the x, and f of x equals 3 times 2 to the x. All right, now what we're going to do is we're going to do this sort of with the help of our calculator, but sort of not. All right, so we're going to complete the table, and then we're going to plot those points on the graph. So first thing I want you guys to do is try and do the tables on your own. We're going to be plugging in these numbers for x, and I need to align my board. So go ahead and try and complete those tables. All right, were you guys able to make any headway? Drew, were you able to complete any of the table? Okay, let's look at this. So we're going to replace x with these numbers. So this middle column is just this, 2 to the negative 2, 2 to the negative 1, 2 to the 0, 2 to the first, 2 to the second, 2 to the third. Destiny, you okay with that? See where I got those from? All right. Now, Delaney, what is 2 to the third? What's 2 times 2 times 2? Well, you did 2 times 3. So 2 times 2 is times 2. What's 2 times 2, Delaney? So 8, 4. Do you see the pattern yet? 8, 4, 2. Anything to the 0 is 1. So 8, 4, 2, 1. Do you see the pattern? What is it? Okay, so what would that one be? Not negative 2. So this is doubling, okay? Do you see that pattern? So you are right, it is like multiples of 2, but it's 8, 4, right? Half, half, half. What's half of 1? 1/2. And we learned about that, right? 2 to the negative 1 was 1 over 2. And then 2 to the negative second would be what? What's half of 1/2? Nice job. So you completed the table. All right, let's look at the middle. All right, this to fill it in would be 4 to the negative 2, 4 to the negative first, 4 to the 0th, 4 to the first, 4 to the second, 4 to the third. Nate, you feeling all right with that? Now, Nate, do you know what 4 to the third is? That's correct. What's 4 to the second? 4 to the first? Next one? 1. 4 to the negative first? So remember, the pattern here was it was being cut in half, right? To go up or doubling. Okay, this is doubling because we're going by twos, right? So let's think of it this one. So this one, we're quadrupling, right? So if we're working backwards, what's 1 divided by 4? 1/4, right? And then maybe what's 1/4 divided by 4? 1/16. Do you kind of see the patterns now? Okay. It's kind of like once you get to the 0, it kind of flips, right? You guys see that? Like here, you kind of view that 1, whatever it is, to the 0th power. That's kind of where your graph kind of like flips and becomes like fractions. Notice we have 4 and 1/4, 1/16 and 1/16. So it can kind of help you out completing the tables without a calculator. And it does the same here. All right, let's look at f of x equals 3 to the 2x, okay? So this would be 3 times 2 to the negative 2. This would be 3 times 2 to the negative first. This would be 3 times 2 to the 0. This would be 3 times 2 to the first, 3 times 2 to the second, and 3 times 2 to the third. Matt, when you are doing math, do you ever look back at the problems you've previously completed? Or do you just keep going forward? You just keep going forward, right? Matt, do you see how this problem is very similar to the first problem, right? Notice it's just 3 times my first problem. So, Matt, what was 2 to the negative second? 1/4. So this is going to be 3 times 1/4. What was 2 to the negative first? So this is going to be 3 times 1/2. And likewise, 3 times 1, 3 times 2, 3 times 4, and 3 times 8. And we can figure that out pretty quickly. 3 times 8 is 24. 3 times 4 is 12. 3 times 2 is 6. 3 times 1 is 3. 3 times 1/2 is 3 halves. And 3 times 1/4 is 3/4. You guys okay with that? Liam, you okay? All right. Now what I want you to do is I want you to plot those points on that graph. All right. The green points on the middle graph and the red points on the right graph. You guys good? Still need a little bit more time? Right? You guys need a little bit more time? All right. So as you're completing these, Sophia, you can't plot all the points, can you? No, like the one for 4 was what? Like 3 and 64, right? It's not going to fit on our graph. And then Drew said, well, how do I plot like 116? And the thing is like, you asked me, okay? It's okay. It's a general idea of how to do it. You guys all right with that? The one thing you'll notice is it's a curve. So far, everything we've been doing is like a line, but these are a smooth curve, okay? So it shouldn't be jagged, it's a curve, all right? And my big thing with all of these is this. When I'm completing these problems, I kind of have an idea of what it's supposed to look like in my mind. So when we graphed lines, it was a line. It was simple, right? We all knew it was going to be a line. But now we're getting into curves, right? And we have 2 different types of curves here. We have growth and decay. Growth is when b is bigger than 1. Notice in each of these cases, that b value, that base was bigger than 1. So I knew it was going to look like that graph on the left that we were talking about. I guess it was the blue graph. So I knew it was going to look like that before I even plotted the points. All right, if b was less than 1, it would be going the other way, flip down. And now it's going to ask me 2 questions here. X-intercept and y-intercept. AJ, where's the y-intercept with the blue question? Where does my blue line cross the y-axis? Very good, 1. So the y-intercept was 0, 1. AJ, what about for the green graph? Where was that? One, right? Because the y-intercept is when x is 0, right? So if we went up to our table and we looked for where x was 0, that's the number we were looking for, right? So AJ, what about for the last one, the red one? Go to 0. 3. And that's because it was 3 times the 1, right? So with these, we kind of like see that 0 is always going to kind of give us like 1. And then whatever that value was in front, that a, that was kind of going to be our y-intercept. You saw that? When we didn't have a number, it was always 1. When we had a number, it was that number. Now, so do we have a x-intercept where our graph crosses the x-axis? No. For exponential growth and decay, think about it this way. if you have something, you keep cutting it in half. Okay, like if I have a sheet of paper and I keep cutting that sheet of paper in half, right? The paper gets very, very small. And at a certain point, it's so small I can't even cut it, right? But that paper's still there. Agreed? So I can never actually get to 0. So there is none. Okay? All right. So now let's do these on a calculator. How can I do this on a calculator, right? Because Liam, I don't want to do this by hand all the time, right? It's a lot of work. So everybody, let's go to our calculator. All right. And the first thing I want to do is hit this y equals button. And we're going to clear out what's ever in there. So let me make sure. Yeah, I got to turn this off. All right. Make sure if your stat plot is on to turn it off. In order to do that, you hit second y equals. Okay. And then if one of these says on, okay, you're just going to hit enter on that one. Brings you to this screen and you turn it from on to off. Okay. All right. So we're at the home screen. Everybody hit y equals. If you have something in there, hit clear and it'll delete it out. And now what we're going to do is we're just going to plug in 3x, 3 to the x. So we hit 3, and then we hit this caret button. Okay, it's up by division. If you happen to download that app. Okay. And then we're going to hit x. Andrew, did you get all that in? Okay. Now we have a lot of things to do. We have to graph it and we have to create a table, right? Both of those are around this button, the graph button. So first, let's go to the table. So we're going to hit the blue button and we're going to hit graph, and it brings us up to the table. And we're going to scroll through the table till we see the points we need. So it says, all right, 0.111. Have you guys ever seen 0.111 before? Very good. So Neve noticed 0.111 had something to do with 9, right? 0.111 is 1, 9. What is 0.3333? 1/3. 0 is 1, 1 is 3, and 2 is 9. Everybody see how I got those? So you do have to recognize some fractions, okay? But remember, if you're looking at this with the pattern, okay, you can see at my y-intercept, it's kind of like symmetric at that point. So it's 3 and then 1/3. And then we have 9 and 1/9. So you can kind of work your way through that. All right, now let's see what our graph looks like. So we're going to hit graph. Okay, if you have a funky graph like mine, we're just going to hit zoom. And we're going to go to 6 for standard. Okay, and notice I have what my graph looks like. So I can come here and I can plot my points. Okay, and I can compare my graph to theirs. So at 0, it was 1, 1 was 3, 2 was 9. So 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6. Yep. And then we had 1/3 and then 1/9. So this one looks like that. Where's my y-intercept? Kanye, do you know where my y-intercept is? So look at your table. Where is 0 for your x? One. So 0, 1 is my y-intercept. What is my domain? Well, my domain is going to be all real numbers. That's the x's I can put in. What is my range? Well, what is y always above? Where is my graph always above? It's always above this line, right? It doesn't go below that line. What number is this? Right here. Somebody said 0. So my range is y is greater than 0. Yeah, you can use that. All right, let's go to the next one. See if you guys can plug this one in. 1/3 to the x. All right, if you're a little lost on how to put it in, parentheses, 1 divided by 3, caret button, x. Then we're going to go to the table. Okay, and notice it's kind of a little different, right? And -2, we're at 9. -1, we're at 3. 0, we're at 1. Then it's 1/3. Then it's 1/9. Why is this one a little backwards? Well, it's a little backwards because the 1/3, right? Instead of it being exponential growth, it's decay. So, in -2, I'm at 9. And then at -1, I'm at 3. At 0, I'm at 1. And then 1/3. So it's going. Oops. This is not as easy as it looks to me, especially when it stops lining up. So what is my y-intercept? Let's 0, 1. Domain is all reals. You okay with that, Kanye? And my range is going to be y is greater than 0.
All rows is just R.
Yep, a little extra line. Okay. Any questions? None? All right, make sure you find your other book. What, chapter 7?